Lab 2, Lines of Charge. In Lab 1, we observed the interactions between charged tapes and between charged tapes and neutral objects. We found that there is an excess charge in these tapes experimentally that leads to these interactions. We analyzed and modeled these interactions as 2-point charges in Lab 1, but in this lab we'll be observing a more accurate line model. As before, we'll utilize 2 U-tapes floating by balancing gravitational and electrical charges, as shown below. We can make 2 simplifying assumptions again to idealize these tapes for analysis. We can assume that the U-tape has the same net charge, and for our calculations, we can treat each tape as if the charges were all located at a single point in the center of the tape. In our computational model, we'll be treating this as a line charge rather than a point charge. We find again that the length of our tape is going to be 0.22 meters as before and 0.22 grams. We determined the excess charge as before and the corresponding number of electrons excess. And then we again compute the ratio of the number of electrons excess to the number of atoms as a whole. When we develop our computational model for this line charge, we find that the numbers vary. The magnitude of the charge on one piece of tape as calculated by the computational model ended up being 3.566 times 10 to the negative 4th coulombs. For this model, we made 2 assumptions. We ignored air resistance on a moving object as before, and we assumed that each U-tape we made had the same amount of charge evenly distributed along the length of the tape. In the previous lab, we modeled the tapes as a single point charge. We can compare the estimated value of the charge from our experimental data to produce the point charge model to the value that we got with this line charge model, and we found that they are quite different. The point charge model produced less of a charge than the line charge model, but we know that the line charge model will be more accurate as it accounts for a distributed charge rather than an assumed point charge. The glow script code is found below.